All right, so measures of relative position. It starts off talking about z-scores, and your z-scores represent the number of standard deviations that a data value is above or below the mean. And so when you talk about being above or below the mean, if your z-score is positive, then that means it's that many standard deviations above the mean. Or if your z-score is negative, it's that many standard deviations below the mean. Once again, since I have this stuff already written out, if I scroll up too fast, you got to let me know. All right, so our formula, remember we talked about the different notation that you would see in statistics. If it's population, your mean would be symbolized as something else versus your sample size. I mean, not your sample size versus your sample. So here we have your z-scores being equal to x minus mu over sigma, and that's your standard deviation. I mean, your mean over your standard deviation. And the same thing here, your data value minus your mean over your standard deviation. So no matter whether you're dealing with your population or your sample, when we look at our general definition to find your z-score, is your data value minus your mean over your standard deviation. Once again, these are just your symbols. Here, your general formula, what you're trying to flow with, is that last one. You're looking at your data value minus the mean divided by your standard deviation. All right, so here's our first example. Raul has taken two tests. He scored 72 on the first test, for which the mean of all scores was 65 and the standard deviation was 8. You received a 60 on the second test, for which the mean of all scores was 45 and the standard deviation was 12. In comparison to the other students, did Raul do better on the first test or the second test? So I'll give you a chance to write that all the way down. All right. So notice we have two different sets of information. He has a first test and a second in which he scored a grade on, and he has the mean and the standard deviation for both. So what we would do is find the z-score for the first test and find the z-score for the second test individually. So for the first test, he scored a 72. The mean is 65, and the standard deviation is 8. So your data value is 72. Your data value is always, or X is that data value, that value that is in question. So that's 72. And once again, the mean is the mean, standard deviation is the standard deviation. So we do 72 minus 65 over the 8, and that gives us 0.875. And on the second test, he scored a 60, so that's our data value. The mean was 45, and the standard deviation is 12. And so you have 60 minus 45 over 12, which is 1.25. And just pointing out the fact that it's always the data value minus the mean over the standard deviation. All right, so the conclusion. So on the first test, he scored 0.875 standard deviations above the mean. Remember, it's positive, so that means it's above the mean. On the second test, he scored 1.25 standard deviations above the mean. So in comparison to his classmates, he did better on the second test, even though he scored a 60. But the key phrase there is comparison, in comparison to his classmates. All right. Let's go to the next one. So a consumer group tested a sample of 100 light bulbs. It found that the mean life expectancy of the bulbs is 842 hours with a standard deviation of 90. One particular bulb from the company had a Z-score of 1.2. What was the lifespan of this bulb? So I'll give you a chance to write that. All right. So you want to know what is the lifespan of the light bulb. So write down, and like I always like to mention when it comes to word problems, write down what is given first before you try to find out, the things that you don't know. So first thing they did was give us the mean, which was 842. Standard deviation is 90. Then they told us the z-score is 1.2. So what we're trying to find out in this case is what is the data value? What is the lifespan in reference to this bulb? The data value that coincides to this bulb. So our formula is x equal to z equal to x minus the mean over the standard deviation. So we plug in what we know. Tells the z-score is 1.2. Our mean is 842, and our standard deviation is 90. So we have 1.2 equal to x minus 842 divided by 90. When you start looking at the solving process, let's walk through it. First thing we would do is multiply both sides by 90, because our goal now is to get x by 12. So we multiply both sides by 90. 90s cancel on the right. On the left, 90 times 1.2 is 108. Then I will add 842 to both sides. On the right, 842 cancels, and that leaves me with 950 on the left. So X is equal to 950. And so that means the light bulb has a life expectancy of 950 hours. All right, questions? All right. All right, Pth percentile. So the percentile represents the percentage of data that is less than the given value. Pth percentile. So example of that, whenever you have, a baby that goes in to be measured, when they go for the checkup, they always measure the baby. And so the baby's weight is in the 85th percentile, babies in the U.S. So that means 85% of the babies in the U.S. weigh less than this baby, and 15% of babies in the U.S. weigh more than this baby. So you're talking about that 85% minus 100. That's how we got to 15. All right. So to find a percentile on a given value, you will take the number of data values less than that number, divided by the total number of data values that you have, and multiply by 100. All right. So on an exam given to 900 students, Elaine's score of 602 was higher than the scores of 576 of the students who took the exam. What is the percentile for her score? Her score was 602, but that's not what we will use to calculate. We see that there are 576 people who scored less um, than what she scored. So she scored higher than 576 people. And then totally we have 900 students who took it. So you take that 576, place it over 900, then multiply it by 100. And that'd be 64. So that means her score of 602 places in the 64th percentile. questions before we go to the next thing? Um, all right, so quartiles are going to be data values that split your data set into fourths. And so we're looking at quartile 1, 2, and 3. And it'll split your data into, 25%. 25% of your data will be, between each value. All right, so finding your quartiles. First thing you want to do, which is a step that a lot of people get, is to list your data values from least to greatest. So you always have to list your data values from least to greatest. And then you're going to find Q2. It's the median of the whole data set. Then you'll find Q1. That's going to be a median of the first half of data. Finally, we'll find Q3, which is the median of the second half of data. So all you're finding are medians. Remember, medians are middle values. and you're going to find the medians. And we already talked about finding medians, what it means, trying to find your middle value. If you have an odd number of data values, then you choose the middle value. If there's an even number, you take the two middle values and find the mean of those two middle values. All right, so let's try this out. Hold on 1 second. I think I'm missing the value. About 45, 45, 42. I'm missing one of my 42s. I knew I was missing something. So it should be 43. So I got two 45s. Okay. All right. So we have 25 data values. So I listed them this way just because I can see what my first middle value is, because I had 25 of them. So I have 12 up top in my first half of data, 12 down bottom my second half of data, and this 43 is in the middle. And remember, your first value that you're trying to find is your middle value of the whole data set. So when I list them all in order, that was step one. So list in order from least to greatest. So that's what I did there. Then I mentioned already that step two, the first thing you're gonna find is Q2. So Q2 is 25. It's the middle value or median of the whole data set. Q1. So now in this first half of data, we're trying to find the middle value of the first half of data. So you would take, because we have 12 data values, we have an even number of data values in the first half of data. So you take both of your middle values and find the mean. So we have 39 in both cases. And that would end up giving us 39. So let's 78, going to go through it. All right. And then final step, we're going to find Q3, excuse me. And once again, we have 12 data values. So we need to find the mean of our two middle values. So that'll be 51.5. All right, questions. All right, so box and whisker plot, or sometimes just referred to as a box plot, it's just going to be a tool that is used to provide a visual summary of a set of data. It consists of your minimum value, smallest value, your maximum value, and then Q1, Q2, and Q3. So basically, if we had to do a box plot of the data set that we just had, we would set it up in the same way. And of course, depending on the number line and numbers and how you have everything set up, this line could be closer to this versus, closer to the right versus to the left and so on. So there's no guarantee to be in the middle, but, we don't have any of that right now. So we can't hold true to how exactly it would be set up. But we take our smallest value, which is 26. Q1 was 39. Hold on, let me make sure on stuff. I put Q2 as 25 right here. Change that. Q2 was 43. And that was y'all fault. Y'all supposed to catch that. But yeah, Q2 is right here at 43. I noticed they put 25. So make sure you go back in your notes. If you wrote 25, some of you may have wrote 43 and just said, man, this dude tripping. But make sure you write 43 right here as Q2 and not 25. For some reason, I made a mistake and put a 25 right there. I don't even see a 25. Oh, it was a 25 data values. I made a mistake and put a 25 right there. But yeah, it's 43, not 25. All right, so our smallest value is 26. Q1 was 39. Q2, 43. Q3, 51.5, right? Yeah, 51.5. Then our maximum value was 73. So that's the box plot for the data set that we just discussed. So your minimum and maximum value, of course, is given in your data set, but then Q1, Q2, and Q3 is what you have to find um, according to what we did last example. All right, one more thing before we are done with this section. Questions? Any questions? Mm. All right, so stem and leaf diagrams. Like I said, this is the last thing out of this section. Your leaf will be the rightmost digit of your data value, and then your stem will be all of the digits that precede the leaf. I can get that out. All of the digits that precede the leaf. So in 25, the number 25, your leaf would be the 5, and your stem is the 2. In 173, the leaf is 3, and 17, or the 1 and 7, would be your stem. So once again, your leaf is the rightmost digit, and then your stem will be everything that comes before that rightmost digit. All right, so I'm going to construct a stem leaf diagram. All right. All right, so we have these data values, this data set. So first thing we want to do is find the smallest and largest value. So we see that our smallest value, our minimum, is 43. And our largest, I see 96, 98. I think 98 is the largest value. Yeah. All right. So our data set is going to go from 43 to 98. So from there, we can set up um, let's see, chart. So from there, we can set up our stem leaf chart. So the way we would do so, just recognize we have stem on the left, and then on the right will be our leaf. And we're going from the 40s. I could have written this as well. I'll stay black. We're going from the 40s to the 90s. Right, since we have 43 to 98, our data set, so that means we're going from the 40s to the 90s. So we got 4, 5, 6, 7, 8, and 9. Let me write that a little better. You know, if we were going to the hundreds, we'd be going from the 40s to the hundreds. So then we would have 10 down here, you know, as far as our stem is concerned. So now for every value in the 40s, I will write that leaf. So notice we have, and we can cross out these values as we go along. We have 43. So I'll put a 3 here for that 43. And the other 40s, I thought there was at least one more. Guess not. Must be missing one. Oh, 49. There it goes. And so then we put the 9 right here. Look for values in the 50s. I don't see any. So what we do not do, if we don't have a value in the 50s, we do not put a 0 right here because that will represent the number 50. If it's nothing in the 50s, then we just leave it blank and then go to the 60s. And normally you try to be in order, but if not, it's not that big a deal because it's what you're trying to represent. But you should look for the lowest value in your 60s. So you see we have 61 here. And I'll tell you why. It's not a big a deal when we get done. Should be one more, 68. Then we go to the 70s if we're done with the 60s. So I see 72, 73. I see 70, yep, 74. And 275s. So if they're 275s, then you write, 5 twice. And 78. Then go to the 80s and do the same. I see 84 is my lowest. I think, yep, good. 84, 85. So I do 4 and 5. Then I see 386s. And then as far as 90 is concerned, I see a 96 and 98. That's it, yep. And so that would be your stem leaf plot. And so, like I said, what you would normally do is put them in order like we did here. Um, what I've seen in the past, the way you would use it, the order really isn't that big a deal because really it's set it up like a bar graph. You could look at it in the same way. You know, it's just different and use different things like this depending on your audience. What would be more appealing to your audience? So, if your audience like numbers better than they like pictures, then you might use something like this to appeal to an audience that likes numbers. So that's why it always pays, especially when you're doing statistical data and presentations, to do research on your audience and see what's more appealing to their vision, to their eyesight, and all the good stuff like that. All right. Questions on 13.3. Okay. So we only have one more section left as far as our new material is concerned. And like I said, we will cover that on Tuesday. So what we leave in next class for is questions. So if you have any questions, you can always bring them on Thursday and we can discuss them and go from there. If you don't have any questions, you feel like you're in a good place, you're good to go. It's not mandatory that you show up for class unless you just want to see what kind of questions people come up with. So outside of that, that's it for today. Any other questions before we close out? Very good. Straight. So if I don't see you on Thursday, have a great weekend. Be safe. And we will pick up in 13.4 on Tuesday. Everybody have a good one.